Hello and welcome to the video on multiplying and dividing rational expressions. So here we just have to recall what it takes to multiply and divide fractions, and the same thing will carry over. So let's just really quick take a look at something like 2/3 times 4/5. And let's just note that when it comes to multiplying these fractions, we can go ahead and multiply tops with tops and bottoms with bottoms, so we end up with 8/15. So the idea is once we have this product, what we'd like to do is to go ahead and reduce. But since 2/3 is reduced and 4/5 is reduced, we know that when we take the product, this product of 8/15 is also reduced. So let's take a look at 3/4 times 8/5. All right, so one of the things we could go ahead and do again is go ahead and multiply tops with tops and bottoms with bottoms, but here we get 24/20. And again, the idea is that we at this point in time have to have our final answer in reduced form. So at this point, 24 is not that big of a number, and 20 is also not that big of a number, so we can rewrite this as maybe 6 times 4 and 4 times 5, and let's just note that the 4's cancel out, so we end up with 6/5. But if we come back over here to the original problem, and let's just note that right off the bat, this 4 goes into 8 twice, and notice that 5 and 3, there's nothing going on. The remaining 2 and 5, nothing to do with the 3 and 1, nothing to do with anything. So we're all done, and notice that if we reduce here, that by reducing I mean get rid of common terms, notice here we end up with our 6/5. Okay, so you're either going to have to deal with large numbers, and again 24/20 is not that big, but what happens when you have something like this divided something like that? It gets a little bit more hairy. So the question then is, well, let's go ahead and reduce right off the top of the bat. So we're going to keep that same concept in mind. So let's just note that if we have 5x squared divided by y times a 3y divided by 7, or times 7x. I'm sorry, so 5x squared over y times 3y over 7x. So again, before we do any multiplying, the question is can we get any reduction? So here I observe that the y's cancel out. Here I observe that this x squared, or that this x will reduce that x squared to just a plain old x. Nothing to do with the numbers, so 5 times 3 is 15. All right, and what's left up top is an x. Then down on the bottom, it looks like we got rid of everything except for the 7. So the product of those two rational statements ends up being reduced and multiplied all at the same time as 15x over 7. So let's take a look at x divided by, looks like 7x minus 21. We want to multiply that by x squared minus 3x divided by 5. All right, so let's just note that there's nothing to factor on the top, so I'll just leave the top here. And notice down here we only have a greatest common factor of an x, so I'm left with x minus 3. And again, up here we have an x, and then we have an x minus 3 here, divided by 5. So now the question is can we start to get rid of some things here? So let's just note that, let's see, nothing with numbers. I have an x minus 3 and an x minus 3. Can't get rid of the 5, can't get rid of the 7. So up top we're left with x squared, and on the bottom I'm left with 35. So product of those two rationals just boil down to that. Okay, so let's take a look at y squared minus 11y plus 18 divided by y squared minus 5y minus 36. So again, the game plan whoops, I forgot, times y plus 4 divided by y. So again, the idea, and what we're going to do is reduce our factor, cancel, and then multiply. So factor, cancel, and then finally do the multiplication. We're going to see that on the division. It's going to work exactly the same way. So let's just note that the top part, let's see, does this factor? So I get a y and a y. So what are the factors of 18? That add up to a negative 11. So I'm thinking negative 9 and negative 2. Let's just validate. So negative 9 times negative 2 is 18. And negative 9 plus a negative 2 is negative 11. So that checks. So we get our y here and our y here. So what are the factors of 36? So I'm thinking 9 and 4. So I'm thinking minus 9 plus 4. So let's just observe that negative 9 times 4 is negative 36. And let's just observe that negative 9 plus 4 is negative 5. So everything checks. So now we get times y plus 4 divided by y. So now we get to start doing our, well, what goes on the bottom, what goes on the top. So notice that y minus 9 cancels with y minus 9. And let's notice that y plus 4 will cancel out with y plus 4. And when we do our canceling up here on this step, let's just recall it's tops and bottoms. So let's just notice up top, the only thing we're left with is y minus 2. And on the bottom, we are left with y. Okay, so that takes care of our first part. And now the second part is dividing. All right, dividing rational expressions. So this is our second objective. So let's just note that numerically we went 3/5 divided by 4/3. So we're going to write this the old-fashioned way. And let's just recall that to divide two fractions, basically the bottom line is we invert the divisor, that is flip it, and then we multiply. So we flip this, flip the divisor, and multiply. So to divide, flip the divisor, and then multiply. Okay, so that's the bottom line there. So notice that nothing cancels out. I'm not seeing any cancelization, so I'm ending up here with 9/20. So we'll just keep that little doodad in mind. All right, so let's take a look at 12x to the 6 over 11x squared divided by 8x over 22x to the 4th. All right, so here we have a rational divided by a rational. So this is going to become 12x squared over 12x to the 6 divided by 11x squared times 22x to the 4th over 8x. Okay. So let's just observe that 11 goes into 22, so I get a 2 there. Let's just note that 2 goes into 8 4 times, so we get that. And note that 4 goes into 12 3 times. So that pretty much takes care of all of that. So x squared turns that 6 into a 4, and x turns that 4 into a 3. So what do we got at the end of the day? I got a 3. I have an x to the 4th times an x cubed, so I get x to the 7th divided by, and then notice everything down here on the bottom, is all gone away. So remember, there's a pretend 1 here and a pretend 1 here. So we get that. So we just write this as 3x to the 7th. It doesn't always happen that the bottom goes away, but it just happened to be that case. Let's take a look at x minus 9, x plus 12 divided by 3x divided by 2x minus 18 divided by 9x squared. So again, a rational divided by a rational. So this becomes x minus 9, x plus 12 over 3x times, so we flip this, so 9x squared over 2x minus 18. So again, now we have to do any factoring if we can. So now we get x minus 9, x plus 12 over 3x times 9x squared. And notice down here I can pull a 2, so x minus 9. So let's note that x minus 9 cancels with x minus 9. And 3x goes into 9x squared, so we get a 3x left over. Okay, so up top it looks like we get 3x, x plus 12 on the top, and a 2 down on the bottom. Okay. And that's all done. Okay. All right. Flip my page here. Got looks like we got 2 more to go. 2 more to go, ladies and gentlemen. So let's take a look. A squared minus b squared over a plus b divided by 2a divided by a squared minus ab. All right, so here we get a squared minus b squared divided by a plus b times a squared minus ab divided by 2a. Now let's see if we can't get any factoring done. So notice we have the difference of 2 squares, so I get a plus b, a minus b divided by a plus b times, and now here we got a greatest common factor, a minus b divided by 2a. So let's see, can anything, a plus b cancels with a plus b, this a cancels with this a, and that looks like about it, right? So we get a minus b divided by 2, and the appropriate way to write this would be a minus b squared divided by 2. This would be the factored form, and this is the, I don't know, appropriate form. I don't know. That's the way we would write it at the end of the day. All right, so our last example here is x plus 2 divided by 6 minus x divided by x squared minus 5x minus 14 divided by x squared minus 4x minus 12. Okay, so now we're going to have to flip and factor and see what cancels out. So I get an x plus 2 divided by 6 minus x times x squared minus 4x minus 12 divided by x squared minus 5x minus 14. Okay, so not much to factor over here, so we get x plus 2 divided by 6 minus x times, so now the question is can we get the top and the bottom to factor? So for the top part, we get xx. So let's see, it looks like I got, so the factors, so for negative 12, let's see, so I get negative 6 plus 2, so let's double check. So negative 6 times 2 gives me my negative 12, and negative 6 plus 2 gets me my negative 4, so that's good. So x and x, So factors of 14, I'm thinking 2 and 7. And I'm thinking in particular -7 and +2. Is that what I'm thinking? So let's see, double check. So -7 times 2 gets me my -14. My -7 plus 2 gets me my -5. So there we are. So now let's see if we can't do anything here. So notice that this cancels with x plus 2 cancels with x plus 2. And then notice that I got 6 minus x and an x minus 6. So this is in the previous video where my difference is, so I'm off by a negative sign. So off by a negative sign. So let's just note that if I could flip the x and make the x positive and the 6 negative, that would be pretty nice to do, and then these two would factor out. And notice that I can do that by factoring a negative. So I get x plus 2, and notice if I factor out a negative, then these flip and I get x minus 6. Now this only works with differences because x plus 6 and 6 plus x are the same. But 6 minus x and minus x plus 6 are the same. But if I want x minus 6, then notice that to flip these subtractions around, you got to factor a negative. Because notice when I distribute, I get my negative x, and then I get my positive 6. So notice I factor my x there. Since these two are gone, then I get x minus 6 over x minus 7. And now notice that this x minus 6 cancels here. But don't forget, ladies and gentlemen, we got that imaginary 1 hanging out down there. So let's just note that we get x plus 2 at the top. And don't forget, we got that -1. And now we have that x minus 7. All right, so when we write our final answer, it's x minus 2 divided by x minus 7. We put that in brackets. Or you can write this as a negative x minus 2 over x minus 7. All right, so that completes our video lesson on multiplying and dividing rational expressions. Let's just notice that to multiply, it's just factor, reduce, tops and bottoms. To divide, flip the divisor, factor, and then cancel, and then multiply whatever is left over. So if you have any muddy points still, please be sure to share those with me in the warm-up. Okay, so outside of that, I hope this video lesson helps. See you in class. Adios.